Yoshua, Bengio, you just introduced in the talk before this one, is a professor at the University of Montreal and the scientific director of Mirella, the recipient of the 2018 Turing Award for his extensive work in deep learning, as well as many other awards. He's also a member of the NeurIPS and iClear advisory boards and program director of the SciFar program of learning in machines and brains, which has been a huge inspiration for the ELLIS network. And the goal of his research is to uncover the principles giving rise to intelligence through learning. Yejin, Choi. Yejin, are you here?
Yes.
Okay. So Yejin Choi is an associate professor at the University of Washington and a senior research manager at the Allen Institute for Artificial Intelligence, working on the project Mosaic on Common Sense Intelligence. She received her PhD at Cornell University, and she received several awards, including Best Paper Awards at AAAI and ICCV and the Borg Early Career Awards. Phil Blunsom, are you around, Phil?
Yep, I'm here.
All right.
André.
Hello. So Phil Blunsom is a professor at Oxford University and a senior research manager at DeepMind, where he leads the natural language group. His research interests lie at the intersection of machine learning and computational linguistics, in particular developing algorithms able to imbue AI with the ability to understand, ground, generate, and act upon natural language utterances. And Mirella Lapata, she is a professor at the University of Edinburgh. She works on the general problem of extracting semantic information from large bodies of text, developing computer algorithms and models in the field of NLP. A research, yeah, so that is it. Mirella, are you around?
Yeah, you can hear me,
okay.
yeah?
Perfect, so we have everyone. So I prepared just a few questions to get started, and then I'll open the floor to the audience. The goal is to have like a informal discussion that touches both open challenges and research topics in NLP, but also a little bit about what can we do in ELLIS, since this is the first workshop of the ELLIS NLP program. So let's get started with the general question. What do you see as the greatest challenges in NLP in the next 5 years? So maybe Mirella can start this one.
You want me to start this one? Great. Okay, at least she said the next 5 years as opposed to the next 10 years. Okay, so there's some small scale challenges and then there's some big challenges. And I will start with the small scale ones and then go upwards. So in terms of the actual research and what we do in NLP, I think there's a lot of things that we ought to be doing, but we are not doing. On the low scale side of things, how we represent and process documents is a problem that nobody is looking at. I mean, people are looking at it, but they chop them up and they think, oh, whatever fits in BERT, I'm going to give to be processed for other modules. That is not so interesting. We need to come up with a way of actually representing the documents and reasonably so that we can actually extract some information from them. So this is on the sort of relatively low end of scale of things. Then new architectures. I do not like these monolithic models. And I was very glad to see that machine learning people like Yoshua are actually moving away from them. I don't want a model that I apply on a task with some label data and I get some predictions and then the model cannot be used again and I have to retrain it from scratch. So I think we need to think about new architectures, about how these modules talk to each other, how they communicate, how they generalize. This is a machine learning problem, but I don't think the machine learning community will solve on its own. They need our help because, as Jamie said, we have structures and structures behave differently. Also, I think we need to go back to algorithms. Today's graduates, all they know is K-best decoding. We have to go back and see how we can introduce more discreteness in the models and use these algorithms with discrete structures. And one final thing, we need to kind of worry about the carbon footprint of these models. And I'll stop here.
Okay, thank you. Yoshua, do you want to go next?
Yeah, I mean, I talked a lot in a brief hour, but to summarize, I would say one of the things that I feel is missing in natural language processing, I mean, there's some work, but not enough, is the focus on understanding, right? So natural language understanding. And I'm afraid that we won't achieve that by just playing with architectures and objective functions or whatever on just larger and larger corpora of text. I don't think this is how we're going to get it. I would go in exactly the opposite direction. I would go and look at, can I build an agent in a simple environment where there is language to describe what is going on and actions and missions and whatever, like a video game, and where the agent can actually understand everything that can be said about those objects in natural language. So the domain might be smaller, but the scale, but even in a small scale, we're not able to do that yet, right? So imagine how could we hope to use our current techniques to have natural language understanding at the scale of the full scope of all the entities and concepts that humans manipulate in a natural language. So I think we're not going to make progress until we can debug these ideas on a small scale and actually succeed to have agents that manipulate language and understand what they're talking about, which we can see through their actions and explanations of what's going on.
Okay, Yejin, do you want to go?
Sure. So I feel like already Mirella and Yoshua covered a great deal of what I would love to see more of. So perhaps just building on that, I totally agree with the viewpoint that the current large-scale monolithic architecture probably is not what's going to really achieve language understanding. And part of that might be due to the fact that these models are not really able to achieve concept representation in the way that humans are able to do. And in addition to looking at a small environment in which perhaps agents can acquire such knowledge interactively, I wonder whether we could also look into maybe more of top-down or larger scale to data-driven approaches where if we might set up the evaluation of current models differently, might it be able to really encourage research that achieves concept representation in the way that humans do? And in doing so, probably NLP as a field have to embrace knowledge and reasoning. For a long time, we sort of assumed that it's someone else's business in AI, not ours, because we are busy doing tagging and parsing, but now we are really past that. And at this point, NLU is not even just about understanding human language anymore. It also needs to understand the brokenness of neural language that comes out of neural networks. And I realized that whenever there's something wrong with neural language, humans have no problem seeing the problem, but machines have no clue because this text is too different from the correct language that they were trained on. So a lot of work to be done, but I would like to see just more emphasis on knowledge and reasoning, not just encyclopedic knowledge that's in the database, but more on the day-to-day, everyday knowledge, like common sense knowledge, or what Yoshua also beautifully represented as, or phrased as, conscious bias that we just have somewhere in our consciousness in a day-to-day business. And I would love to see more of that as well.
All right. Phil, what's your take on this question?
Well, obviously, lots of great points there raised that I can agree with. To continue Joshua's theme from his talk, structure is obviously just a hugely important thing for language processing that we're still not very good at. I feel, if anything, with deep learning, we've got worse at dealing with structure. We've gotten really good at building models that avoid structure and just get around it and discover the correlations. And we can build massive language models that do really well on perplexity and things like that. But if we actually want to do anything with them, useful beyond sort of simple classification tasks. If we want to act in the world or anything like that, we need some sort of structure, as Yoshua said, causality, and these sorts of things that we can actually link to action and such things. So we need to get much better at structure. We're still terrible at that. If you look at what we feed into transformers with like pairing codings and things like that, they're often complete nonsense from a sort of word structure point of view. So we can't even really discover basic structural words, let alone causality. But then beyond models and things like that, we need to get better at evaluation. A lot of evaluation is not terribly robust in the field. We've gotten very good at convincing ourselves that models work, getting papers out, but often these are not really robust results. So we need to get better at evaluation. And I think also we need maybe some new and more interesting tasks. We tend to do a lot of translation and parsing and language modeling and speech recognition, which are great tasks that really challenge modeling and have led to lots of interesting results. But again, the sorts of things people are talking about here, like language understanding, it's not clear that we're making progress on language understanding from getting better at these tasks. So maybe we need to look at some different tasks. And that's hard because if it was easy, we would have come up with them, but we need to look at different sources of data or reward functions and things like this.
Okay, thank you. So there is a question posted in the chat by Nico de Cal that makes a good bridge with what we discussed in this first round. So structure seems cool, but should we define a good enough formalism for semantic representation, or should we leave neural networks to learn one by themselves? We have had instances of both as keynotes and invited talks in this workshop. So maybe I can bring some disagreement here between the panelists and trigger some interesting discussions. Like, can we learn the semantics from our data? Should we use declarative knowledge or have a formalism that allows us to do that from linguistic annotations? What is the role of linguistic annotations to learn semantics? So maybe we can start with Mirella because she looked excited when I started asking the question.
This is such a kind of worms kind of question. Yeah. Okay. So there have been in the past tons of linguistic representations of semantics, starting with lambda calculus, moving on to, I don't know, DRT and AMR, and they have different pros and cons. They have variables, they don't have variables. I don't know that we can actually annotate these things to a good enough and reliable level so that machines can learn from them, and we would need a lot of data. Okay, there's that thing. The second thing is that I think we cannot talk about general semantics disassociated from the task. So different tasks would require different kind of semantic representation. So in semantic parsing, for example, which is mapping natural language to structured representations, to do things like asking questions with Alexa or the Google Assistant, the trend is that we have to use SQL. SQL is like the best representation for this problem. If you talk to the Google people, they will tell you, no, we don't need the semantic representation. We just have calls directly to the APIs. Now, so I think we need to say semantics for applications versus semantics for representation. And then when we do semantics, when we want a general semantics for everything, then I don't think we will be able to define a representation. So this representation would have to be a graph that is word-based, things like Ido was talking about. So we use, and I'm not very happy with this either, but at least we can see this and we can learn it, define the meaning of words with using other words. And I'll stop there, and others may say what they think.
Okay, Yoshua, what is your opinion on this topic?
As I said earlier, I think semantics need to be anchored in a low-level perception and action. And so I think trying to define semantics at the symbolic level is always going to fail. I mean, it's going to work for things like arithmetic. Yeah, we can do it all at the symbolic level. But the kinds of things, many of the things that humans care about and communicate with language have a a non-verbalizable knowledge component. And so what I think we need to do is to impose structure on the learning, but allow the learning to discover that hard to formalize semantic knowledge that each of the entities and mechanisms or verbs or whatever carry with them. So it's a mix, right? I don't think we can do it just with sort of pure, completely blind, non-parametric learning with like homogeneous neural nets, and we can't do it purely with symbols. It's going to be something that has learning of the pieces in such a way that you end up with the right properties that humans seem to exploit when they think and speak.
Okay. Phil, what are your thoughts?
So, I mean, as I said, I'm very keen on structure, but I'm very unsure whether that structure is best represented implicitly or explicitly. Obviously, at the moment, the pendulum is very much on the implicit structure side, and implicit structure is just much easier to discover than explicit discrete structure. But I feel we're definitely going to need to discover the structure. We're not going to be able to annotate it and learn from that. But at the same time, we need to know what we're looking for. We need formalisms. We need an understanding of the linguistics. Otherwise, we don't really know how to bias the models, because you definitely need a strong bias in there to learn any of this stuff. It's not just going to come from just some big neural network. So we need everything in terms of understanding what we're looking for, the structures we're looking for, the sorts of operators we want, but then how we get these biases into models. And as I said, we need people exploring explicit representation of structure, discrete structures, but also implicit continuous structures and such things, because we really don't know the answer at this point.
One thing I could add is, I think when you talk about semantics, you really want, I think, to jointly learn the world model, like just forget about language. How does the world works? Like, what is the causal structure? And the linguistic structure that relates that understanding with sequences of words. And so if you try to do the latter without the former, I think you're going to have trouble really catching even very simple forms of understanding that a 2-year-old has of their environment.
For example, time. You cannot learn time without being embedded in the world, and you cannot learn it from text either.
Right. Yes. And causal effects is something you basically have to have an agent that does things in an environment. So I think the way we're going to get natural language understanding is initially is going to be through virtual environments where the agent learns both to manipulate language and to understand how the world works through their own actions.
Okay, so there is a question that kind of relates a little bit to this. So from Jonathan Behrens, there is some research that is trying to see what happens if you create like a small controlled environment, a simulated environment, and there is research that tries to attack these problems in the wild. What are the pros and cons of both approaches? What can we learn from both sides? Maybe Yejin, since we.
Yeah, that's great. And then maybe I could also address for the previous question a little bit in relation to this environment as well. So I'm a big fan of this multimodal research directions, and then I'm also playing with the Thor currently for that reason. But it's both good and bad. In the Thor environment, I can throw an object to the wall and then see what happens and learn that if I throw glass, wine glass, it can break. And if I throw a ball, it might not. But there's limitations to what I can experiment with in that environment, because it's really limited to whatever the software engineer was able to implement. And so unrealistic things can also happen. And I don't know how we are going to scale that up eventually to really create even a small kitchen in which I can bake bread in the oven and, you know, burn it just a tad too much so that maybe part of the bread is not edible anymore, but the inside is okay. And I don't know how accurate that simulation will ever be. But perhaps I could also go back to Yoshua's earlier comment about how we cannot truly learn what bread means without having this perceptual connection. I agree and disagree simultaneously in that to some degree, the perceptual signal or perceptual grounding is, perceptual grounding is really, really important, but that's not the whole thing that's really missing in language understanding today. I think in some low level, perceptual level, that's what's really missing. But we also need to ground the meaning of a bread, the meaning of wine glass, for the social context in which we use such word and objects and interact with as well. So, for example, wine glass has a bit of this social connotation that, or, you know, it may be more like evening time activity if it's alone, done alone. If there are two glasses, it sort of implies that there are two people drinking something together. And probably that those two people were not fighting. I mean, they could have been fighting, but maybe they were having more of a social time as opposed to trying to write deep learning papers separately. So I do think that this sort of context does matter a lot. And in fact, I really liked how yesterday Julia gave a talk about this connotation of language that can have like microaggression or unfair biases against marginalized groups. And exactly that's the kind of stuff that's missing when we just focus on linguistic formalisms that focus more on syntax and semantics that are a little bit too close to the words that are in a sentence. So for a lot of a microaggression or a biased language, the meanings are really not exactly in the word or arguments or the tree structure of the sentence, but really the implication comes from the common sense understanding about the social implications. And we need that kind of formalisms going forward, which is not about parsing a sentence into a predefined nice tree structure, but being able to generate all these implications that people tend to make for a given sentence or utterances of a language. So maybe for that reason, when people say formalism, I do wish that people work on it more, but perhaps really broadening the scope out of the more familiar linguistic formalisms, but really touching on pragmatics and more of these meanings that arise from a word or a phrase or sentence that's not necessarily married to the word themselves in a sentence.
Okay. Any more comments about this topic from the other panelists? Okay, so I think we can move on to a different one. So NLP systems interact with humans. So let me shift gears a little bit towards like human-centric AI. And it was pointed out earlier that models that are getting more and more impressive performance, like language models like GPT-3 and so on, we are at the stage where they are starting to be productized, but they still have a lot of failure modes. And in general in NLP, since these systems interact with humans, in many cases it's important also to interpret their decisions, which goes to the topic of explainability, for which there is a lot of research. How can we understand why a certain prediction has been made? How confident is a system on its prediction? So what are your views on explainable AI and its role in NLP? Maybe more broadly, not just explainable AI, but all these things that we are still not capturing. So maybe I can start with Phil here, because he has some work on explainability.
Well, my thoughts are it's a really difficult topic, yes, I have done some work with students, and the more I thought about it, the more sort of confused I got about what exactly we're trying to explain and what it means to explain a model's decision. Obviously, you can have models that have specific structure, that causal structure that's interpretable, and classic sort of graphical models and such, and you can explain them in a mathematical sense. But as soon as we move away from that, it becomes very hard. And when we have models that sort of give predictions and then output explanations in some natural language, what does that really mean? Does the explanation have to connect to the decision anyway? And obviously, all of these things are mirrors of the problems we have with humans. When someone does something and then you ask them why they did it, and they give you an explanation, does that explanation correspond to why they actually did it, or do they do it for some other reason? And then it all just comes back to trust. So I think in many ways, explainability and modeling has to come back to trust, some sense that you have over time that a model is reliable, some sense that it's been demonstrated. But it is, it's a difficult problem to actually formalize what exactly we mean. And when you look at different sort of research papers and the ways what they're referring to as explainability, often they're quite different, but people are comparing very different underlying sort of assumptions about explainability and on the same sort of outcomes. So there's not really a great deal of agreement of what it really means to explain something. So do I have anything? I'm not sure I have much more useful to say besides that. It's very difficult. And well, we need to think more about it. There needs to be more thought about exactly what does it mean to explain something or have a model output natural language. At the moment, there's a lot of people doing it, sort of generating models that generate explanations in some way. I think less discussion of what it actually means to explain.
Okay, this is an interesting point. So we need to formulate the question better. What is explainability and what we are trying to do? Okay, so what are others' views on this topic? Yoshua, do you want to go next?
Sure. My view on explainability is connected to what I said earlier, that in order to have explainability, let's say, of the kind that humans are able to provide, okay, let's not even try for now to do better than humans, because they're not perfect at that job. I think we need to explore the sort of structure I mentioned, where we have sequential processing of these entities and mechanisms that correspond to maybe an interpretation of what is being perceived or a plan about what we could do or could happen, at a level that is easy to translate into natural language, because you're talking about a discrete, discrete sets like these modules and entities and mechanisms I talked about, and attention mechanism can select in a soft or hard way, potentially a few of them at a time to form a part of the explanation. But so I see the explanation as just a reflection of the conscious processing that is being performed. If we're able to do system 2 like inferences and planning and so on, then explainability at that level will come almost for free. That's what I'm trying to say.
Okay. Yejin?
Yeah. So it seems that there are just like roughly two different types of explanation. One is more like attention or gradients, where things are much more grounded in the low-level neural network parameters or information inside. And then, but these cannot really explain in the way that humans can understand. And depending on different tasks, if the task required the story understanding and you ask a common sense question about why someone did what they did in a story, then the correct answer may not even be a text to spend in the story anymore. And at that point, it's not even clear if we just look at the attention and gradients, what sort of reasonable answer even we get. And so ideally, we want I think personally that neural models should be able to explain in human language as well, just for lack of any better ways in which we can understand what the machine might explain about their decisions. But if we are okay with that, by the way, humans also explain themselves in human language, and we cannot really share our brain, I don't know, MRI photos in order to explain why we made a certain decision at a time. So But what's really good about, I think, human explanation to other humans is that if we think whether that's actually truthful or not to their true decision-making process, that's a different thing. But if we realize that, well, there's a flaw in your reasoning, and in fact, in the future, when we make a decision, maybe we should consider this other aspect more. And maybe there was some misunderstanding about some knowledge, in which case we can make a correction. And so we can, in fact, communicate all this, and then people can on the fly adjust their understanding or knowledge or priority so that they make a different decision. And I think that sort of interactive plug and play modification to the neural network would be desirable in the future, that we can communicate with neural network in symbols like language to update their whatever they believed or prioritized on. And so explanation might need to tie to the ability to modify the neural network behavior for it to be really useful if produced in language.
André, you're muted and we don't hear you.
Sorry. So there is a problem that appears to be a little bit simpler than explaining a prediction, which is just providing a confidence measure. And our models can still do that, right? NLP systems, they often fail with high confidence. Are these two things related? Do you think they are different? Any thoughts on that?
I mean, models can be confident without knowing how wrong it is. So,
but how can we calibrate them so that when they don't know, they know that they don't know?
Right.
Yeah, I think we could. So there's work going on in machine learning on what people call epistemic uncertainty, which is really about estimating how wrong a particular prediction is. It could be a probabilistic prediction, it could be classification, it could be a continuous value prediction. And especially focusing on the part of the, decomposing that error into the part that can be reducible through further learning, and the part that is inherent in the data, in the underlying distributions and the underlying noise. And that's useful to know if you're going to be asking questions. For example, you want to ask questions about the parts that you can learn from, whereas you might not care about asking questions for which no amount of feedback is going to help you understand better because it's part of what's unknowable.
Okay. Mirella, you still haven't talked about this part. What are your views on explainability and confidence, all this?
Okay, so I'll be a bit controversial, and I personally don't care about explainable models. So, and I will qualify this. There is a very nice paper. I do recommend that people go and read it, by Cynthia Rodin. I'm not sure I pronounced her last name correctly. She's a professor at Duke University, I believe, and she has a paper whose title I'm going to read out to you guys. It says, "Stop explaining black box machine learning models for high stakes decisions and use interpretable models instead." So if explainability is a big deal, and if you don't want the doctor to make a mistake, then you don't have to use a black box neural network model. By all means, use something else that you can explain. Okay, there's this part of the thing. What I want, and what the discussion was hinting at, is, so till Yoshua gives us this interpretable model that explains itself and we don't need to do anything, we may perhaps have models that we can debug. I think as people who build these things, and this is kind of different, I think the two are confused. So the confidence intervals will help me debug my model. More things, visualizing attention, making sure that, my gradients propagate. These are all practical things that we can do. But whether or not we care about the model explaining why it made the decision, I personally don't really care, because I don't work with doctors, but maybe somebody else does. And in that case, we don't have to use these models. And I'll stop there. And maybe we can move on to your next question, because I don't want them to say to me and they disagree. Yeah, go ahead.
I want to say something about what you just said. So I kind of agree with most of the things you're saying, but there's one place where I disagree. I think there's a trade-off between explainability and sort of accuracy of these models, right? And so if you think about what humans do, we kind of cheat and try to have it both ways. So we're using our intuitive system one abilities to take decisions that are very difficult to explain in detail. And yet we do come up with an explanation or like a rationalization or whatever. But we also know, I mean, if you have a little bit of introspection, and that these explanations are not the whole story, and kind of everybody knows that. So if you go back to the practical scenario with your doctor and so on, I think what you want is to have a very precise prediction or decision making that's been optimized, maybe in a black box way that's hard to explain. But you can also have a different model that is trying to give you a simplified explanation of what is going on. So long as the two predictions are more or less, in agreement, it's not such a bad thing. And you can, so long as a doctor understands that these are two different things, you can have either something very accurate or something simpler to understand, and he can look at both, right? Or she can look at both.
Okay. Okay, so I have one last question, and then I guess we can, move it or invite questions from the audience. This is not about research. I mean, it's about research, but not at the technical level. It's this is the first workshop of the ELLIS NLP group, and everyone is asking, okay, how can we move forward? What else should we do? And I would like to know, maybe starting with Yoshua and his experience with CFAR, that as often you pointed out in your talks, it has been a key to advance research in deep learning. Like how can we and what lessons can we learn from the development of AI research in Canada, in the US, in the case of Yejin, and what can we do ourselves in Europe to promote collaborative research? And the particular case of ELLIS NLP is interesting because we are a very diverse group. There's more than 10 institutions represented as fellows and scholars in this program. So there might be some additional challenges, but I'm very curious to hear from your past experiences what we can do here.
So one of the things that CFAR provided us was a sort of safe space where we could talk about our half-baked ideas, unpublished work, and it was a small enough group that we all trusted each other and could criticize each other in a gentle way, and because you see the same people over and over for several years, you develop something not just in terms of collaboration, but also, as I said, trust and kind of knowing their research program. So this more intimate connection you don't usually get in the typical conferences where we go to. There's too many people, and it's a bit formal, and you typically wait for your ideas to be proven by experiments or theories or whatever before you talk about them. So it's more like the good old idea of workshops, but it's more than that. Like a workshop is usually a one-off thing. But here it's more like you develop a little community of people who know each other, trust each other, talk to each other, can collaborate, but mostly get inspiration from each other, and feel very free to criticize, feel very free to talk about things that are not mature, and so on. So that's, I think that played a big role.
I was muted again. So any concrete things in terms of what you did for networking? Like, did you often participate in projects together? Did you Q-supervise students often? Add student exchanges? What kind of initiatives were helpful that we could also implement here?
Yeah, I don't think there was like anything forced upon us. But for example, there was money for paying pretty much anybody, students or faculty, who wanted to travel between the different places and collaborate, or our funding for students who would like be the electrons between the different atoms and create a glue on particular projects. So there was sort of collaboration money, if you want, and easy travel money for any of the members. So that helped, but yeah, I don't think these things should be top down. Like, collaboration cannot be ordered. So, you know, people may come together for a grant, for example, because they think they're going to increase their chances of getting the money by complementing with this other person. But if there is no chemistry that really works, it just becomes an artificial collaboration, just to say, okay, we've worked together and maybe we put our names on a paper and some of that stuff. But real collaboration is something that's more like at a human level, and it's more like a bottom-up thing. And so it's, how do you create the environment where these bottom-up connections and corridor discussions that normally happen inside our department can happen between colleagues who are in different institutions. And that's sort of thing that I think CFAR helped with.
Okay. So, you know, one of the missions of ELLIS is also to promote, to have a societal impact and to promote transfer of knowledge between academia and industry. And this is a topic that I would like to bring. We have a few people in our panel that have joint appointments with industry. Maybe we can start with Phil. How do you envision collaboration between academia and industry in the scope of ELLIS, and even before ELLIS, how have things worked for you?
I don't know. Maybe I'm too biased, but in the NLP field, I mean, we're incredibly connected with industry. Obviously, as I have a biased outlook on that, but even before joining DeepMind, like NLP at conferences, we're constantly mixing with academic researchers, industry researchers. So I think we should be in a much better position than many fields. So I think there's lots of things that would be nice but are hard problems, and the barriers between working easily across industry and academia, and a lot of those are bureaucratic and legal, often put up by companies or universities, concerns about intellectual property and these sorts of things. And I think on the boring side, lots more could be done to make those easier, in terms of the sort of things that ELLIS could do, making it easier for students to move across between academia and industry. That's still quite a difficult thing, but there are no real practical reasons, and that gives access to sort of the computational resources that industry has, and the sort of talent and ingenuity that students bring. But at the moment, there are lots of bureaucratic problems with that sort of thing. That's sort of at the governmental level, but in many ways, one, I'd echo all the things that Yoshua said, sort of supporting bottom-up research, bringing people together across both academia and industry, generating trust, which in my experience, trust really in research only happens in small groups. It's really, you can't get 30 people together and really expect them to trust each other and work well productively. But you can get sort of 3 to 5 people together and get really productive groups. But yeah, bottom up is key, not coming up with like grand schemes that, okay, we decide that we're going to have a big project on solving language understanding and have lots of money for that. That's just we might agree that's a good idea, but it's a good thing to solve, but it's a bad idea to do it that sort of way. Instead, support people bottom up, as Yoshua said, with travel, funding for students and student travel. These are all great things that really generate connections. But yeah, on the industry side, it's sort of boring, but the biggest problems are bureaucratic. From where I sit, there's no real reason that we shouldn't work a lot more easily across academia and industry, but there's bureaucratic barriers that don't really make sense, but they're there, just because like we don't have a standard PhD funding template that companies can go to. Often companies will want to interact with students, but it might take a year of negotiating with a university's legal department to make that happen, and then companies don't want to do that and they walk away. So having standard things in place and things like that make a huge difference, but that's all very boring.
Okay, so I guess the first step is kind of removing these bureaucratic obstacles and let things move forward. So Yejin, I'm curious about how things work for you with the Allen AI Institute and UW. Like, do you also have these bureaucratic problems that Phil pointed out?
No, but maybe because I'm not trying to pay somebody from UW grant. And also that AI2 is non-profit, and so I'm okay to collaborate with anybody in any company, and no need to get any approval about publication prior to submission and so forth. So that's great. But I found that personally, internship is great, that I can take students from AI2 for internship. And of course, that's increased advising that I have to do during the summer, which means I'm trying to get rid of as many of my students as possible to somewhere else. And I think that's good all around for everyone. It's a little, I mean, maybe there's a bit of discontinuity per usual, but I think students learn more by interacting with different people. And also I get the opportunity to learn new students in different universities and grow to have a better relationship with them. And then sometimes we also invite their advisors to advise our projects a little bit. I mean, depending on how much of a time they have, of course, they can be flexible with that. But I found that really nice, especially when I send my students to somewhere else, the same thing happens, and it's all around good because then I get to think about new problems that I may have not thought about before. And I found that works quite well. And I wonder within ELLIS whether you could do some informal student exchange. Maybe it's not as much as formal internship, especially for people who are in the same time zone. And we kind of got used to working remotely as well. So it might work okay. And for that, maybe it helps to have like reading groups and seminars to get to know each other better. And for that, probably the top-down structure helps a little bit for people to meet each other and get to know each other a little bit better, I imagine. Yeah.
All right. Okay. Mirella, what is your take on this? What can we do to collaborate in ELLIS NLP?
Okay, so I think when this nightmare is over, we should all meet in person. I mean, there's no way that I don't think it's good, but it's not going forward. It's staying put. So, okay, aside from the fact that we should meet in person and there should be breakout rooms and we should have interested parties to come up with ideas and blah, 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 blah. We could also think about making some impact with the decision to actually do a data set that addresses a problem that some of us think is very important and put our intellectual power in there, and then there will be a brand. And if people use it, or multiple data sets or multiple tasks, this will involve some money and some time, but at least there will be some people behind the name and some tasks behind the name. So we can do all of these things with the students and the exchanges, but people are busy. Sometimes students don't want to move, and they take students, they don't take students. So 2 ideas: we have to come up with specific projects, and then people can work on these projects, and this cannot be top down. We have to have a common interest, but I think that will not be hard. There's many people in ELLIS, and many of us have common interests. And the other one is if we can, or we want to do something bigger, and that we have to discuss. Okay, and I'll stop.
Okay, and does anyone want to add anything else before I open the floor to the audience?
I just add, just on the concrete ideas, one thing from CIFA that was really good is they have a every year pre-NeurIPS workshop, because most of the people from SIFA were always going to Europe. So on the weekend before Europe, they'd always have a workshop and get together. And I think Yoshua would agree that that was very successful at getting people together. And it would be easy to have a pre-ACL ELLIS NLP workshop or something like that.
Yeah, you want something regular where people meet physically.
Physically, we see each other properly.
And so, a conference where most of the members go is really, and they don't need to do an extra trip. Like, I don't like traveling, but if it's part of an extra day or two of an existing trip, then that's okay.
All right. Okay. So, do we have any question from the audience? I see several questions in the chat. So maybe if we can either go back to research, or we can keep talking about how to collaborate more in the scope of ELLIS. So there is a follow-up question by Irina. Irina, do you want to ask?
Yeah, thanks. I was just curious. Mirella said we could do something bigger together. If Mirella has any suggestions, what this could be.
A task and a data set, but it would have to be like not downloading something from the web. We would have to put some thought in the task and how we would actually create this data set, and then a leaderboard where people, this is how people get noticed these days. Another thing that we have not touched upon, but I always worry, and in fact, when I cannot sleep at night, I always think about this, and I don't know whether ELLIS can do anything. The problem, and it pains me to say this, the problem of actually having enough computation to do our work becomes more of a problem as AI becomes more successful. They're almost like diametrically opposed to each other. So I don't know whether we can make an ELLIS center for computation where there's gazillions of, I don't know. These things are like maybe pie in the sky, but this is a real problem, and universities are playing catch up with industry. And I fear that at some point, this is my worst nightmare, we won't be able to catch up anymore. And we will be reduced to sort of, I don't know, making transformers smaller so that we can run them in our machines. We can have some initiative like, I don't know, green AI or small carbon footprint or whatever, and put the ELLIS, rubber stamp it with ELLIS. I don't know. Yeah, these are like just ideas. We don't have
All right, thanks. Very good ideas, but let's leave time to somebody else also to ask questions.
Yes,
thank you.
About sort of green AI, just for your information, our group put out a library called Code Carbon. If you're writing in Python, then you can just stick a call before and after your main computation, and keeping track of where you are, like physically, and basically on where's your server, it can estimate the carbon footprint of your computation. And then, you can monitor that using a nice user interface and so on. Code Carbon, it's called.
Okay, you still have 5 minutes. More questions?
I guess I had a question before. So it was related to what Yoshua talked in his talk about systematic generalization, and it went pretty quickly for me maybe about, you said that of course it doesn't make sense to expect like random changes in distribution, like for our models to generalize to random distribution. And I think you said something like that on some abstract level, the change should be small. So I was just wondering, is this like a necessary and sufficient condition? Is this the definition for like what it would make sense? Like, what are your thoughts on like?
So these are the changes in distribution that humans can explain with language, right? So not every change in the world is something we can cope with easily, but pretty much all the things we can cope with easily are things that we're able to verbalize, what has happened. And when we do that, we point to, one or a handful of entities and an intervention or some explanation, basically, what has happened and potentially, what are the consequences. So in other words, what I'm saying is we might not be able to come up with machine learning methods that can deal with any change in distribution, but at least we should be able to deal with those changes that humans are good at handling. And they have that property that we can kind of abstract the change to, in a very sparse way, to a few entities that have been modified, usually by some agent.
Yeah, maybe I will let you do also. I guess I was just saying, like, maybe sometimes like these changes are more dramatic, but are still explainable by like some abstract structure. Like
right, exactly. That was the point of my dark glasses example. That it's a dramatic change at the level of pixels, but it's a tiny change in the abstract space of like verbalizable concept. I put on my dark glasses. And so what we need are machines that can discover these kinds of abstractions. They could be guided by interactions in natural language, and then do this sort of causal inference about what has happened at that level, so that you can adapt, you can explain and you can adapt to those changes more easily.
Thank you. Very interesting.
So you can formalize that mathematically. I mean, people working on causality have ways to say what I'm saying in math, but it's the same idea.
Thank you.
There is a question by Ido Dagan.
Yeah, no, I'd like to refer to go back to the issue of possible activities in ELLIS, and I connected very much to what Yoshua said about the cipher, that they were kind of developing trust and getting to know each other. So I guess by the number of people, maybe ELLIS is larger.
Well, ELLIS altogether is larger, but I think if you take the
ELLIS NLP,
ELLIS NLP, I don't know how many like leading faculty are there.
20.
So it's about the same size.
Same size, yeah. But I guess also with respect to diversity, so I think if we have such pre-conference workshops or any other kind of physical gatherings, maybe one thing is to allocate a substantial amount of the time to let people group in smaller groups based on common interests, and maybe spend some more time both on presenting informally, not just regular presentation, but more informally the research, and maybe more so their ongoing research, and also leaving time for other people to respond to that. Like I'd love to have some time with some of the people here that I know are close to my areas, and get feedback, and so on, and so vice versa.
The idea for us was that we typically have as much time for discussion for any intervention as there's time for the presentation.
Right. Yeah.
So and it's hard to enforce because people want to use all the time to speak. But it takes some discipline.
Actually, yeah, but I think
some whip.
You know, I'm not sure. I think if I get used to it, I actually would like to spend more time listening to what others have to say about, you know, my work rather than what I can tell more about my work. I know what I have to tell, right? I don't know what other people think about.
Yeah, but it's also engaging, like engaging in the discussion. So you take the habit of feeling okay to comment, question, ask. When the group is small, you can afford to ask a question simply because you didn't understand something. You can interrupt in the middle and say, "Oh, wait, I don't understand. Why are you saying this?" So this is the kind of presentation. It's not a formal thing where the person speaks and then at the end, okay, we have questions. It's something that's more interactive all the way.
Right. So you are also splitting to smaller groups, if I get it right.
Yes.
Yeah.
Yes.
So
yes.
And I think maybe we have a little bit of experience for those who attended Dagstuhls. There is something a bit similar, but I think that maybe the big advantage of ELLIS NLP over Dagstuhl is that there is continuity. So if we, let's say, meet physically once a year and then maybe have a virtual gathering, so overall we maybe get to interact every half year or so, then I think momentum can be built up. Often in Dagstuhls you have some great ideas, but then everyone goes back on their business. But if you do something continuously for some period, I think the chance that people will, from these discussions, find common interests and opportunities to collaborate increases.
And also, Ido, don't forget that at some point there will be joint students that will take things forward. this would actually was impossible. People were imprisoned in a castle and drank wine for a week, and then they went back, to do their business.
Yeah.
Okay, so this is a wonderful discussion. I wish we could spend more and more time going in this discussion, but we have a keynote starting in 10 minutes, and now there is a break. So thanks again to all the panelists for making the time to be here. This was extremely helpful. And the workshop is going to continue in 10 minutes.